Hello, this is Mrs. Tempest, and this is the book on the periodic table. The periodic table is a table that lists all the elements. An element is a compound made up of only one type of atom. So, for example, the one that is here is gold. So, gold is going to have only gold atoms. The periodic table organizes all the elements in very specific ways that are meaningful to scientists. The periodic table organizes all the elements according to how many protons they contain and how many electrons are in their outer shell or orbit. Now you might remember that these are going to be equal to each other. This way of organizing the elements keeps those that are similar grouped together. The periodic table is made up of columns and rows. Each row is called a period, so those are going horizontally on the periodic table. As you go from left to right in a period, the number of electrons in the outer shell increases. Finally, as you go across the period, the number of protons also increases. This means the atomic mass, or how much the atom weighs, also increases from left to right. There are also columns in the periodic table. Each column is called a group. This helps scientists predict how an element in the same group will react. So now we know the periodic table is made up of periods and groups. Now let's look at an element on the periodic table up close. Each element on the periodic table has the same and important information. The atomic number tells you how many protons are in the atom. The atomic symbol is an abbreviation for the element's name. Some are harder than others to figure out because they use the Latin names. So one thing that might seem familiar to you is how we abbreviate states in the United States. So Wisconsin is abbreviated WI. We do the same thing with elements. The atomic mass tells you how much the atom weighs. It is also the number of protons plus neutrons in the nucleus. So our atomic mass is equal to the protons and the neutrons when we add them together. There are three main types of elements in the periodic table: metals, metalloids, and nonmetals. So we see the metals in pink, the nonmetals in blue, and the metalloids in green. The metals have similar properties. They are usually solids, shiny, and are good conductors of electricity and heat. So I want you to take a second and try to think of some metals that you might be familiar with or where you might be familiar with them. Some things that come to mind for me are fixtures on all of my bathroom things, like my sink and my shower. I also think of my car when I think of metal. And also money, so thinking about the coins that we use in everyday life. Metals are also very ductile. This means that they can be pulled into thin wires. So a lot of times we use the metal copper to do electricity things in our homes. Metals are also very malleable. This means that they can be hammered into thin sheets. So I think a really good example of this is aluminum. Now think of aluminum foil that you might have seen someone put on a dish or a food that they bring to a buffet. We have aluminum foil that is really, really, really thin, and it's able to be bent without breaking. Nonmetals are just the opposite of metals. They are not very ductile or malleable. So usually with nonmetals, if we try to bend them, they're going to break, and we're not going to be able to pull them into thin wires like we are with metals. Nonmetals are not very good conductors. In fact, they are often used in insulation to prevent the loss of heat. So that means that metalloids are somewhere in the middle of metals and nonmetals. Metalloids tend to be partially conductive. This makes them valuable when creating computers. So basically with metalloids, we can have them react and turn as conductive as we need them to be. Metalloids can be solid or liquid and usually are ductile and malleable like metals. There is a lot of information packed into the periodic table. Each element has its own properties and unique characteristics. Hope you enjoyed the book.